This video is making equivalent fractions with sums of fractions with like denominators. Big idea is we're adding fractions together, they have the same denominators, and we're seeing what they're equal to. Let's look at the first one. 1/3 plus 1/3. You guys should be able to do this looking at it. Okay, again, we're going to start with our number line. Okay, and remember from last lesson, okay, we're going to start with our 0 and 1, and we're going to split this in 2/3. And I have 0/3, 1/3, 2/3, and 3/3. Now remember, it's important that we are counting the spaces, not the lines. Okay? So from here, we are going to go, we're starting with 0, and we're going to 1/3. Okay? And then we're adding one more third. Okay? When I end up, I have 2/3. Okay? I can also write this as 1/3 plus 1/3 equals 2/3. This works because I have the same denominator. If I had a different denominator, it would not work the same way. Now I can rewrite this not just as 1/3 plus 1/3, which we already did. We can also write it and say that it is the same as 2 times 1/3, because I have it twice. Which, again, if I solve that, I have 2/3. Let's look at another problem. 3/8 plus 3/8 plus 1/8. Okay, put out your number line. You can also do the rectangles if that works well for you. Okay, here I'm going to divide it into eighths. I'm going to start with drawing a line in the middle because that helps me. Okay, and I'll go fourths and then break it down even more into eighths. Okay, then you label it. And I'm going to do every other because I know, and look, I'm already making mistakes. I know that I can use my information from before and use my context clues. Okay, so starting at 0, going to 1, okay, I'm going to go 0 to 3/8. From 3/8, I'm going to add 3 more, and I'm going to count 1, 2, 3. And then I have 1/8 more, which takes me to 7/8. Again, I can write this as an addition problem because they have the same denominators. 3/8 plus 3/8 plus 1/8 is the same as, I have 3/8 twice, so I'm going to do 2 times 3/8 plus 1/8. Don't forget about that last part. Okay, and that is equal to, or the same as, 7/8. Okay, rewriting 6/2. Now we know that 6/2 is greater than 1, because if 2/2 is equal to 1, then 6/2 must be greater. So instead of drawing one number line, I'm actually going to put in a few, because that's going to make it more clear. Hopefully. Okay, so I drew out that number line, and I labeled my big idea points, 0, 1, 2, and 3. Estimating for 3, and going from there. Okay, 6/2, or 6/2, excuse me. Okay, I have 1/2, 2/2, 3/2, 4/2, 5/2, and 6/2. Okay, and remember, this is the same thing as writing 3. So when I want to write it down, I have 6/2 is the same as 2/2 plus 2/2 plus 2/2, which is also the same as 3 times 2/2. And remember, 2/2 is considered a fractional 1, which is means it's equal to 1, so 3 times 1 is 3. Okay, 8/5. We're going to do it just like we did the other problem. Okay, we know that it's going to be greater than 1. Okay, and we're labeling our parts. Then we will break it into fifths. Once I'm here, I remember that 5/5 is the same as 1, so I'm not going to bother labeling this section here because I already know where those are. Okay, and when I add, I'm going to go do my 5/5 and then add 3/5 over. 1, 2, 3/5. Okay, for a total of 8/5. I can rewrite this as 8/5 is the same as 5/5 plus 3/5. And looking up at my picture, I know that I have one whole and 1, 2, 3/5 left. So it is the same as 1 3/5. Okay, last problem. Rewrite 7/3. Try it on your own first. Now that I draw my number line, again I put the thirds in the whole numbers, and I'm going to reason for the rest. So as I draw my line, I'm going to go 3/3 to 6/3, and I have 7/3 total, so I'm going to go one more, which is 7/3. When I rewrite that, I can do it as 7/3 is the same as 3/3 plus 3/3 plus 1/3, which is the same as 2 times 3/3 plus 1/3, which is 2 1/3. Okay, you're looking to know that you can rewrite the problem in multiple ways. Okay, not just go straight from 7/3 to 2 1/3. What is actually inside it?